Okay, Eddie asked for two problems. That was the only email I got last night, so I've got two problems to go over. Number 27, and this one's a little bit weird because it really does look like it's going to use one of those formulas, but then it ends up not using one of those formulas. So it's all about the U substitution for this one, so it's a little bit tricky. U, try that again, one more time. U is, we're going to let that be 1 minus x squared. So du is going to be negative 2x dx. Right, so that means that down here I'm going to have the square root of u, and then if I put a du out here, that's going to take care of my x and my dx, but I've introduced a negative 2 that I wish wasn't there, so that I'm going to have to put a negative 1/2 in order to compensate. So if I rewrite this before I actually take the integral of it, it's going to be u to the negative 1/2 du, and now I can integrate that just like I normally would. So u to the 1/2 over 1/2, which was already times the negative 1/2 out in front. So that means that these two things will cancel, and I'm just going to end up with the integral being negative square root of u, which is negative square root of 1 minus x squared. And then, since this one was definite, I get to evaluate that from 0 to negative 1/2. So when I do that, I'm going to get a negative square root of 1 minus 0 minus, so that's square root of 1, and square root of 1 is 1, and then I have the opposite of that, minus. In here, if I square, I'm going to have the square root of 1 minus 1/2, actually negative 1/2, squared, so that's going to get me 1/4, so 1 minus 1/4 is 3/4, so I'm going to get minus a negative square root of 3/4. And we're going to have to fix that a little bit, but basically you can punch that into your calculator even though it's not proper, and that'll still get you negative 0.134. Alright, so that was 27. 32 looked a lot more like our example from yesterday with the completing the square, and it was in the completing the square section, except this one was definite, so it means I'm going to have to plug stuff in at the end. But basically, I want to complete the square down here, so I do not want this to be a 13. I would prefer that to be a 4. So I can't just change the value of the problem, but I can change the way it looks. So I'm going to go x squared plus 4x plus 4, and then so that that still remains 13, that means that I'm going to have a plus 9 out here. And now I'm going to factor that part. So I'm going to have the square root, or the integral of negative 2 to 2, dx in the top. This is going to be an x plus 2 squared plus 9. Now I'm going to let u equal that x plus 2, which means du is going to be dx. Also means that now this is u squared plus 9, and because addition is commutative, I'm going to switch those orders so it looks more like the formula, because that one always goes a squared plus u squared. And now I can just plug it right into that formula, which would be 1/3 arctan of u over 3, because my a is going to be 3, because that's a squared is 9. Alright, and then because this one was definite, I can plug things in for it. So I have to evaluate this one from negative 2 to 2. So 1/3 arctan of 2 over 3. I'm sorry. I should probably put the u back the way it's supposed to be first. 1/3 arctan of x plus 2 over 3, and evaluate that from negative 2 to 2. That's better. So 1/3 arctangent of 4 over 3 minus 1/3 arctangent of -2 plus 2 over 3. That's 0 over 3, which is 0. All right, well, the inverse tangent of 0 is just 0, so this ends up going away. My real answer is this, and the decimal approximation for that is 0.309. So let me know if you guys have any more questions over any of those homeworks that we've done in the last couple days, if you pick some out. And then especially want to make sure that we go over any questions that you have over the review, which is page 477 through 90. That's a little bit of everything that's going to be on the quiz when you guys come back on Monday.